In this video, we're going to be looking at lesson 6.2 on properties of parallelograms. The essential question is, what are the relationships between the sides, angles, and diagonals of a parallelogram? First, it's important to understand what a parallelogram is. A parallelogram is defined as a quadrilateral with two pairs of parallel sides. Do not assume that something is a parallelogram unless the sides are marked parallel like they are in this diagram, or if you're told that it's a parallelogram. Notice in this picture, you can see that side AB on the left there is parallel to side CD, and side BC is parallel to side AD. When we name a parallelogram, there's a new symbol that we're going to use, and that symbol is right here. So that's the parallelogram symbol. So if I wanted to name the parallelogram in this picture, we need the parallelogram symbol followed by 4 letters, and the letters are just going to be the vertices of the parallelogram. You need to pick a letter to start at, and then you have to go around the parallelogram either clockwise or counterclockwise. I'm just going to go this direction, kind of alphabetical order. So I'll call it parallelogram A, B, C, D. When you have a parallelogram, there are some special properties that apply just to parallelograms. If a quadrilateral is a parallelogram, then its opposite sides are congruent. In our picture, let's mark the opposite sides congruent. That means that PQ is congruent to SR or RS. And also, QR is congruent to SP. There isn't really a name for this theorem, it's just a property of parallelograms. So you can either use the theorem number, which is 6.2-1. The 6.2 refers to the lesson number, 6.2, and then the 1 is the first theorem. Or you can abbreviate it like this. Parallelogram symbol, that means if it's a parallelogram then, and then we'll go opposite sides congruent. So that is going to be our abbreviation. The second property of a parallelogram is that if a quadrilateral is a parallelogram, then its opposite angles are congruent. So opposite angles would be like angle P and angle R, so those are congruent. And angle Q and angle S are also congruent. You can abbreviate this theorem in the same way that we did for the one above it. So if it's a parallelogram, then opposite angles congruent. Or you can call it theorem 6.2.2. The third property of a parallelogram is that if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. And recall that supplementary just means that they add to 180 degrees. So in my picture here, angle P and angle Q are consecutive angles. And we know by this theorem that the sum of the measure of angle P plus the measure of angle Q is equal to 180 degrees. And there's going to be other options for the consecutive angles, like I could do Q plus R equals 180. So if angle P is X degrees and they're supplementary, the one that's right next to it is just going to be 180 minus X degrees. You can abbreviate this as if it's a parallelogram, then consecutive angles are supplementary, like that. Or you're welcome to just call it theorem 6-2-3. That's the third property of parallelograms. All right, that brings us to our final property here. And for our final property, if a quadrilateral is a parallelogram, then its diagonals bisect each other. The diagonals in this picture, I'm going to put 2 different colors on them. So we have QS, and we also have PR. So those are my diagonals. What this theorem is stating is that if this is a parallelogram, the diagonals are bisecting each other. That means where they meet, it divides the diagonal into two equal parts. So that QM is congruent to SM, and the other diagonal is also bisected, so that would be PM congruent to RM. The way that you can abbreviate this one, there isn't really a nice shortcut. Parallelogram, arrow, diagonals bisect each other. So make sure you have these properties filled in. We're going to be using these properties for the examples today and also again in lesson 6.3. All right, let's try an application problem. In the directions here, we are given that in parallelogram KLMN, LM equals 28 inches. So LM is this part right here, that's 28 inches. LN is 26 inches. Notice that LN is one of the diagonals. And that LN is equal to 26 inches. And then the last piece we have here is angle, the measure of angle LKN is 74. LKN is going to be this angle right over here. Let's try a brighter color here. So that's angle LKN, and that's going to be 74 degrees. And now that we have our picture filled in, we should be able to use the four properties to find the missing measurements. Let's start with KN. Notice that KN is opposite the 28 inches, and in a parallelogram, opposite angles are congruent. So that makes KN 28 inches. You don't have to justify here, but for your notes, it might be helpful. The property I used was if it's a parallelogram, then opposite sides are always congruent, and that is theorem 6-2-1. Next up, we have the measure of angle NML, and NML is this angle right up here. Notice how it's opposite that 74-degree angle. So we know that in a parallelogram, opposite angles are congruent. Let's move now to the MLK, angle MLK. So angle MLK is not opposite the 74. It's right next to the 74. These two angles right here are consecutive. And we know that consecutive angles of a parallelogram are supplementary. So MLK, its measure, is just going to be 180 minus 74, which is 106 degrees. The property I used was if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So you can use that abbreviation, or it's fine if you'd rather use the theorem numbers from your note packets. That's fine too. That's theorem 6-2-3, and the one we did right before this is theorem 6-2-2. Finally, for this last question here, there's a couple mistakes that need to be fixed here. PT, there's no P or T on the picture. That should say LO. And then there should be angle O right here in the middle. So please correct that, add an O to where the diagonals intersect, and cross off PT and change it to LO. Well, notice that the diagonal, the big diagonal, LN, in the green, is 26 inches. We know that the diagonals bisect each other, which means that NO is congruent to OL. So if the total is 26, that's the total diagonal. If we divide that by 2, we get 13. That means LO is equal to 13. Here's a quick try now for you to try on your own. It's very similar to the problem that we just went over. Please mark up your diagram with the givens. Read these angles very carefully so you make sure you find the angle we're looking for. And then let's have you pause the video now, and when you hit play again, the answer will be posted. And here are your solutions. CF is 74. It's just opposite DE, which is also 74. The measure of angle EFC is the supplement of the angle that's given. So you're going to do 180 minus 74, that's 106. And then DF is the full diagonal. And if half the diagonal is 31, the full diagonal is just going to be 31 plus 31, or 31 times 2. Either way, we get DF equals 62. The next type of example that we're going to be looking at here in our notes is using properties of parallelograms to find measures. We're told that WXYZ is a parallelogram, so we can use all 4 properties that we discussed at the beginning of this lesson video. To find the measure of angle Z and the measure of angle W, we're probably first going to need to find B. Notice that these 2 angles, W and Z, are consecutive angles, and consecutive angles are supplementary. So if we make an equation here, measure of angle Z plus the measure of angle W has to total 180. Now we can just set up our algebra. 9b plus 2 is the measure of angle Z, plus, and then we have 18b minus 11. And together that adds to 180. So we combine our like terms, 9b and 18b is 27b. And then 2 minus 11 is negative 9. Now if we add 9, 27b equals 189. You can then calculate 189 divided by 27. And when you do that, you get 7. So now that I know what B is equal to, now I can find the measure of angle Z. And since I'm kind of writing too big here for my slide, I'm going to just put it down here. So for part A, we want the measure of angle Z, and that is equal to 9b plus 2. Since b is 7, we just take 9 times 7, we add 2 to that, and that is 63 plus 2. So the measure of angle Z is 65 degrees. Next up, we can find the measure of angle W. The measure of angle W is this 18b minus 11. So that's 18 times 7 minus 11. You multiply that out on your calculator. It's 126 subtract 11. And when we do that, we get 115. All right, so that just completed part B. Now we have part C. So for part C, we're going to have to do a little bit of work here because YZ doesn't have a B in it, YZ has an A. So on my picture here, notice that these 2 sides are opposite sides, so we know they're going to equal each other. So to set up the work for letter C, I'm going to do 6a plus 10 equals 8a minus 4, and then we'll go ahead and just solve that. I'm going to move the 6a to the other side. And then I'm going to add 4 to get 14 equals 2a. We divide, and a is 7. Now that I know what a is equal to, I can go back and figure out the answer to the problem. YZ, you can see, is just 8a minus 4. And since a is 7, we do 8 times 7 minus 4. 56 subtract 4 is 52. Here's a quick try now for you to try on your own. It uses all of the properties of parallelograms that we discussed today. Note that on number 2, that 3x plus 17 is with angle R, and the 130 is with angle S. Please pause your video now and give this a try. When you hit play again, the answer will be posted. So here is your solution. You can check out the work that I've shown. And that concludes this lesson video. Thanks for watching, and good luck as you try some problems on your own. Bye.